It's really kind of informal. We're just kind of here to educate you and kind of try and help out where we can. So if you have any kind of questions or anything like that, just feel free to just hop in, send questions in chat as we're talking. Don't be ready to disrupt us or anything.
Yeah, that's the thing. You can hear people talk about an introduction to Java and an introduction to programming anywhere. Like there are definitely like thousands of videos on YouTube, which can show you that. We are here because sometimes you just need to ask a question, or if you do get lost, just being able to ask people to slow down. Like there's so much value in that. Please, please, please utilize that. We're friendly people. We don't bite. We're some of the nicest people I know. So definitely at any point, if you have a question, message them into the chat or raise your hand and we'll ask what's going on, because that's the value of being at like a live workshop at the end of the day. Yeah, let's look at these responses. All right, so most of you know, I've heard of Java or know what Java is. Perfect. So no one hasn't heard of Java, which I guess is fair given the title of the workshop. Pretty even split when it comes to methods, about knowing what they are, having heard of them, and not knowing them at all. System.out.println. Most of you have heard of it. Some of you haven't at all, but of course some of you have. Booleans, most people know what they are. Classes, most people know what they are. Object-oriented programming is a straight up 33.3% split between no, yes, and I've heard of it. Most people don't know polymorphism, and same for inheritance. Interesting. Okay, so yeah, this is perfect. We are going to give a very, very beginner overview. People who do know like a majority of the stuff I mentioned in that form, just have some patience. It's always valuable to go back to the basics. Making this PowerPoint was valuable, reminded me of a lot of things that you just forget over the years. But yeah, excellent. So let us know when you want to get started, Nikhil.
Yeah, for sure. So you'll be screen sharing that PowerPoint, right?
Yeah.
Yeah. All right. So I think we'll just take another minute here just to make sure that everyone's in and everyone's answered. And then, yeah, we can get it going as soon as you want, man. As soon as you're ready.
Excellent. We can wait a minute. Yeah. So yeah, Akil will just be keeping an eye on the chat, answering any one-off questions you may have. Shes and I will just kind of distribute the slides amongst ourselves. But yeah, feel free to ask a question in the chat, or just raise your hand, turn on your mic, say stuff. We're not that big of a group. We'll be fine. Can everybody see that?
Yeah.
Excellent. And you'll notice there's another name on there, Megha Madakali. She's actually she's my co-director. And she was going to be here and we were going to do this workshop together, but something came up. But she did make like a large majority of these slides, so huge kudos to her. And then yeah, Shrestha and Akil, you have met. Excellent.
You good to start, or are we waiting on something?
No, I think we're good to start, right? Whenever you guys are ready, go ahead.
All right, then we'll go ahead and start then. So yeah, this is an introduction to Java. Welcome guys. Once again, want to emphasize, any point, just pop a question in the chat or raise your hand, unmute, talk. It's all good. That's what's going to make this experience most valuable for you guys. And at the end, we'll give you resources to learn more. But yeah, let's get started. First off, what is programming? Everyone kind of has like a sense of it, but basically when you write code, you're writing instructions for the computer to do certain things. And what the computer does is that it compiles it. If you've had the experience with programming, you know what that means. It'll compile it, which is basically it'll take in the code that you have written, and given the grammar that it is taught to understand, it'll take those instructions and it will do them. And what a grammar is, it's basically, what is grammar in English? It's the different rules as how you should be writing something in order for the computer to best understand you. So if you look at that example, you see these random curly brackets, you see random parentheses, random square brackets, semicolons. All of these have roles in the grammar of a computer understanding something. So when you write code, you just have to abide by those rules of grammar. In computer science, we call that syntax. So you abide by the syntax of the programming language. And if you do, the program can understand what you're trying to ask them to do, and it will compile. And it'll run exactly what you ask them to do. And that's half the battle, because sometimes what you ask them to do isn't actually what you wanted them to do. And that's when debugging comes into play. But that's basically the gist of it. When you're writing code, you're giving the computer instructions in the language that they are asking for. And the language we're going to be talking about now is called Java. Shrestha, if you want to talk about that.
Yeah, so Java is what we would call an object-oriented programming language. And so what this does is when you write your code, you're defining objects in a way that sort of models the way they interact in real life. So for example, you might have a school object, and a school would have many students. And objects have properties and they have actions that they do. So these are like fields and methods. So a student object, for example, would have a name, a grade, a GPA, and then actions would be like attend class, enroll in a class, things like that. Yeah, and so you have the option to define classes, which serve as a sort of blueprint for objects that you can then make from them. And so when you write your code in Java, it's interpreted by the JVM, which is the Java Virtual Machine, which then helps it run.
Awesome. So now we're going to kind of just talk about what does a Java application look like? What does that code look like? And they all follow pretty much the same structure. And once you understand that, you'll understand what code is actually doing, and it'll give you a better understanding of how you can make your own code. So this is a very simple Java application where if you click run, it'll do something. So first of all, as Shrestha said, it's an object-oriented programming language, meaning everything is going to be within their own classes. Now, main class is just basically when you click run, what class it'll go to. That'll be the main class. And then you see this public static void main string args. That is what is going to conduct as soon as you press the run button. And that's a method. So first thing is just it'll be in a class, and that class is main. Next thing that's in this example is public. So what does public mean when you're talking about this method? This method's name is main, but what does it mean if that method is public? It being public means it can be accessed by any program on your computer. So if you have multiple classes, a method in another class could call this main method from the main class. Sometimes there is a benefit to making it private. I doubt you all will ever have to make it private, but just the reason you have to specify it is because there are different functionalities when it comes to who can access a certain function. And by the way, I know I'm using function and method interchangeably. They can be used interchangeably. Sorry, I didn't mean to confuse any of you. Next would be the static keyword. That static kind of describes whether a method belongs to an instance or a class. So kind of going back to the example Shrestha said, there's a difference between a class and an instance of the class. Now, a class could be students. All students have this, this, and this, but each specific student does like a certain action. If you want a method that applies to the class, like let's say all students, you make it static, meaning all students would like have to update a GPA, like well, actually no, you would set the GPA of an individual person. My apology. That would be an instance method, but a static method would be something that's conducted on the entire class of students. Now here, it's a static method because it's just the entire class of main where this method is running. And then there's void. Void is what the return type is. Some other return types would be different variable types. So you could return a string, which would be like a series of characters, like hello world in this example is a string. We'll get more into the variable types later. You can also return like numbers or anything. But if you just want a method that does something, like just conduct an action with this input, then it would be a void method. But if you want that method to give you an output, then you would have to include and specify what the return type is here. And then just main is the name of the method, and in between the parentheses are the parameters, which is what the input of the method is going to be. So if it's like a machine where you put something in and something gets spit out, it's what you are putting in. And when you do that, you have to specify what the type of the variable you're putting in is. So string bracket bracket args, we'll get into that more later, but that's essentially saying this is an array of strings called args, args being arguments. And this is standard throughout all Java programs. Every single Java program has a main method like this. And whenever you click run on a Java program, it'll run this method. So you'll see this everywhere. So it's very important that you guys understand what it is. And I think that is it. For the sake of time, I will pass on this. I was gonna make you guys type this up in an editor and write it yourself. But spoiler alert, what it'll do is that when you click run, it'll run this main method and it'll see this instruction, system.out.println, hello world. So system is the actual operating system. .out says you want to output something, and the command line where you're running it, and println means print that line, and the line's contents are hello world. So that would display hello world on the screen for you.
Yeah, so now we're going to talk about classes. So as I mentioned before, Java is an object-oriented programming language. And so in order to make those objects, we need to define classes. So classes are kind of like a blueprint of an object. So in this example, you see like a class fruit, and it has various properties or like fields. So that's like lines 5 to 7. You have like an integer defining the number fruit, a string, which is the name, and just like a Boolean true false if the fruit is rotten or not. And then at line 9, you have a method / function. And so that kind of defines what the object can do. So once we've defined this class, we can use the class, or like the class will serve as a blueprint for us to create objects from it and like instantiate objects, which we can then use in our programs to represent different things and have them interact.
Awesome.
So going back to the fruit example, basically the fruit has different properties, which we showed as variables, and they also have different functions. So with the properties that the fruit object class has, so when you define variables, you can have like two different types of variables mainly. So you can have primitive types, and then you can have objects. So in Java, primitive types are, there's 8 of them. So 2 of them are int and Boolean. So int is just like an integer, Boolean is true or false. In this code snippet here, you can see that like it's blue. So the text editor like recognized that like we're talking about a primitive type. So it like recognized that as like a keyword. And so there's some other types. There's double, which is like decimal. And so you have primitive types, and then you have objects. So string in line 6 is an object. This also includes objects that you create. So like I could create a fruit object and then use it as a variable in another class. Yeah.
Awesome. So that is kind of the organization behind like more complicated Java programs, right? You make a class, you name it however you'd like, and you give it certain attributes, like, and they're at fruit, number of fruit, and qualities about that class. Now to actually put some logic behind the instructions that you give, or I guess just instructions in general, there are a certain number of statements that are certain types of statements that you can use. The first one we're going to talk about is a comparison statement. Now this is pretty simple. You show the operating system that we have two things. If this one is greater than another, or less than another, less than or equal to, or greater than or equal to, then do something. And we'll talk about that if comparison, use then, greater than or equal to, or greater than or equal to. Pretty self-explanatory. But to check if two things are equal, something weird Java does is it uses the equals operator. You have to put two equal signs, and that's because there is an instruction that the operating system has for just equal signs, right? When you say int I equals 10, you're assigning 10 to equals. So since that instruction has a certain syntax in the code, Java basically made a new operator when you want to ask if two things are equal to each other. And that would be the equals all operator. And then same, if you want to check if two things are not equal, you use exclamation point equals to. And by the way, don't expect to remember these things. Google is your best friend. I'm sure you've probably heard like half of software development, half of coding is like intelligent Googling. We'll send you some good websites to keep have a tab open, like whenever you forget something, or more likely when you forget something. It happens to everyone. It's pretty much standard operating procedure, but just to understand why things are happening, we thought we had mentioned this. So these are an example of 3 different statements. So if you have 10 apples, 13 oranges, and 13 bananas, these would be true. Like if you assign each variable to have a numeric value, so apples would be less than oranges because 10 is less than 13, true. Oranges would be greater than apples because there are 13 oranges and only 10 apples. And since they're the same number of oranges and bananas, equal to would be true. Now the output of these statements is just that, either true or false. It's a Boolean. And with those true or false values, you can do a certain number of things. Like for example, the biggest one is probably an if statement. An if statement is basically only execute these instructions that I have within this block if these values are met, or if the condition is true. So here we have a if statement that looks at a student, and that'd be a student object. And when you do student object dot something, you're looking at that attribute of the student. So let's say there's a student class and there was a was nice variable that was either true or false. Now, if student.wasNice is true, if that Boolean statement is true in the if statement, only then it'll go inside of the code block, which is denoted by the different curly brackets. Only then, after meeting this condition, will it execute the commands inside of the code block. But there are also probably certain scenarios where you have to check for multiple things, or if condition A is true, you want to do this, but if condition B is true, you want to do something else. And that's why with if statements, you also often see else statements or else if statements. So if you have another if statement, I'll just walk through this example, right? So if the student was nice and that's true, then it will give them candy. But if that's not true, it'll skip down to the else if statement. And here it's asking if the student was on time. If that's true, then it'll at least give them those instructions. You can also put another if statement underneath an if statement. And if that's the case, if the first if statement is true, it'll also conduct the second if statement. But if the second if statement's kind of exclusive, like in this example, if somebody was nice and on time, they would only get candy. If you make the second if statement just an if statement, they would get a candy and a ribbon if they were both nice and on time. So there's a small difference between the two there. And finally, there's just an else statement. So if none of the conditions were met, then you can execute whatever code is written in the else block. I have a feeling I might have been a little confusing there just by the way I phrased things. So if any of you are confused, let me know in the chat. You can always just ask questions. Akil will be looking at it and answering them. I also think that's Hindi in the chat. I do know Hindi if you want to ask questions in Hindi.
Yeah, guys, be sure to ask questions. You can also privately message either one of those three to get those questions answered.
Yep, feel free to privately message Akil. Did you want to talk about for loops?
Yeah.
Shasta?
Okay, so for loops are
Actually,
basically...
wait, before we move on, we did have one question. Repeat the difference between if and else if. All right, just in this example, oops. So if, all right, so basically if you have two if statements, it'll check both of the if statements. The program is compiled like top to bottom, right? So it'll read the first if statement. Oh, this if statement was true. Let me execute that code. Then it'll go to the next if statement. And if it's also true, it'll execute that code. But if you want the second statement to only execute if the first statement wasn't true, like if the student is nice, if they weren't nice, okay, but were they on time? Then you would use else if. If you want to skip the rest of the else ifs, use else if you want, if the first if statement is meant to be true. If you want the rest of the statements to be skipped, that's when you use else if.
So basically, when you use if-else if structure, only one of the statements gets executed. If the first one's not true, it'll just keep going down and checking if anything else is true. If nothing else is true, it'll execute whatever's in else. And if you don't write anything in else, it'll just move on reading the rest of your code.
I think, yeah, that makes more sense. Thank you, Akil. Perfect.
Yeah.
All right.
Okay, so for loops. For loops are basically a way to execute like the same block of code multiple times until a certain condition is met. So kind of like an iterative process. Go to the next slide.
Sorry.
No worries. Okay, yeah. So in this example, basically what you have is the for loop syntax is such that, so you have three things separated by a semicolon, right? So the first one is the starting condition. So you start with a student count of 0. The middle one is the condition that must be met for the for loop to run. So once that condition is not satisfied anymore, if student count is more than 20 or equal to 20, the for loop won't run anymore. And then the last one is the update. So student count plus plus, so that increments student count by 1 every time the for loop runs. And so what this code segment does is 20 times it'll execute the method give student candy. And what's interesting about for loops is that the condition that changes, like student count plus plus, so student count changes every time. It goes from 0 to 19 inclusive. And so you can kind of use that variable in the for loop and sort of like change what the for loop does each time while it's executing as well. So if I wanted to print out like give nth student candy, so like give the first student candy, give the second student candy, I could print that out every single time. And so like there's ways that you can like modify what's going on in the for loop, even if it's technically the same block of code that's running.
I have a question actually. what's the difference between, so that middle statement, student count less than whatever, it's the conditional, right?
Yeah.
What would be the difference between less than and less than or equal to?
So so we're starting at student count is 0 and we're going up to 20, but not including 20. So the for loop technically executes from 0 to 19 inclusive, so that's 20 times. But if it was less than or equal to 20, then it would execute 21 times. So that's something to watch for when you define your for loops. Check if you're starting at 0 or 1, and then check if your condition has less than or equal to, like greater than or equal to. And so that'll like make a difference in your code, how many times it's running.
Someone in chat asked, how do we change the increment?
Okay, so like the last part, student count plus plus, think of that as like a basically a line of code that changes anything that changes that value. So you could do student count plus equals 2, or you could do student count like plus equals 10, whatever you want. Yeah.
I don't know if we
So,
explained the plus equals syntax, but that if you use like student count plus equals 1, it basically means like student count equals student count plus 1 or student count plus whatever. It's just shorthand in Java.
Yeah.
there's so much shorthand like this. We don't expect you guys to remember it, but we'll make sure at the end of this to send you guys the links where you can easily find these things. Yeah.
Okay, so another type of loop is the while loop. Basically, it's while a certain condition is met, keep running this segment of code, and then once that condition is not met, don't run it anymore.
Yeah.
Yeah, so in this example, while number of candies is greater than or equal to 0, give student candy. So if give student candy increments number of candies by 1 each time, for example, this statement or this block of code would run infinitely because number of candies would keep increasing and it would always be greater than 0. But given the context of the method name give student candy, we can assume that like for like the purpose of this example, number of candies would reduce every time you give a student candy. So let's say we start off with number of candies equals 100, and then we give 1 to each student. At a certain point, we'll reach number of candies equals 0 and then -1. And then at that point, the while loop would stop executing. Something to note is, and this is like a fun exercise to try on your own, while loops and for loops can always be converted to one another. So when you write something as a for loop, like take a step back and ask yourself, would this work better as a while loop? And then when you write something as a while loop, do the same, because while they can be converted into each other, there's oftentimes like a good fit based on your program.
I got a question about that. So what would you use to determine, when you're determining what loop to use? Would you use the condition that's given?
So one thing is code readability and how easy it is to understand what's going on. So like sometimes there is a clear fit. So the for loop gives you like more like there's more of a definition to the for loop, whereas the while loop is just like one condition. And so if as you're writing the for loop, if it feels like you're making up stuff to fill in those three parts that you're defining, then maybe a while loop would be a better fit. A lot of the times, both of them work, but then there's sometimes when like using a while loop as opposed to the for loop would make your code much more readable or much easier to understand.
So one big thing is scope. When you declare whatever is being incremented in the while loop, you declare it outside of the scope of the while loop, which means that you can then use it later in your code. When you declare a variable in your for loop, you can only use that variable within your for loop.
Yeah.
So just to kind of show what he means by that, with for loops, like here, we made the variable student count in the for loop, and we incremented student count in the for loop. And once we did increment it 20 times, we met that value, we exit the for loop, student count no longer exists. Now with the while loop, if we have number of candies here, we could be working with number of candies throughout the program. Like maybe before this, we had some method to acquire the candies and we could increment it then. But now we're going to give away candies until it's 0, and we will still have access to number of candies afterwards.
Great explanation. Thank you.
All right, perfect. I want to do a quick checkpoint. Did anybody have any questions about loops in general, for versus while, or questions about each individual one? I'll give it a second. And while we do that, I can introduce the next section, which is methods. A method is basically if you have like a certain set of instructions that you want to repeat, like whenever something happens. Sometimes you just want to put that in, package that in a method. Method is basically when you call a method, it'll call all of the instructions within that method. So just as an example, this is something we're going to show you from a larger example. But let's say you're making a game and you want to end the game. There are certain actions you have to do in order to end the game, right? So this method will take in an input, whether or not the computer won. So if the computer won, then it would do something else as opposed to if you won. Let's pretend like we're actually playing a game, right? So the main method could call the end game method with the parameter of whether or not the computer won or not, and it can just wrap up the game. So if you call end game boolean true, meaning the computer did win, it would go to the first if statement, computer won is true, and it would output to the user system.out.println, you lost, try again next time. But if the computer didn't win, else, it'll say congratulations on winning the game. We had sort of talked about the syntax of making a method earlier, but I'll review it again. First is the scope of it, whether it's private or public. Most likely, if you're a beginner with Java, it doesn't really matter. As I said before, though, private can only be accessed within that class and that file, and public can be accessed from many other classes and many other files. So if you're making a complicated Java program where dogs have to be able to conduct a method for pet trainers, then it would be like a public method. The second is static. Static is whether the method belongs to the class or to an instance. This is probably the most confusing one. So if you don't get it, don't worry, don't lose patience. But the difference between static would be and non-static would be whether a method is for like all, like a class in general. Like if the species of dogs does something, it would be a static method for dogs. But if not, it'd be an instant method, like Rufus.bark would be an instance method. If it was like dinosaurs, then like going extinct would be a static method, but eating smaller dinosaurs, what do dinosaurs eat? Birds, perhaps? Humans, maybe? But if it was like that, then it would be an instant method, like a specific dinosaur will eat a human. And then there's the parameter. And the parameter, you have to specify what the variable type of the parameter you're taking in is. And you can have multiple parameters. But effectively, what a method will do is it'll segment your program. So if you have like a functionality, like every time somebody wins a game, this should happen, or every time somebody gets hit by something, this should happen, you should most likely put it in a method with those parameters. And the parameters will be every variable that you need to conduct the actions within the method, just so you can avoid rewriting that every single time. And trust me, you could pull off building a really complicated program with no methods at all, but the segmenting it will save you so much stress when it comes to debugging things and to even understanding your own code. When I started out, I wrote programs which I truly could not understand if you asked me to, but it worked somehow. But segmenting it into methods is what helps do that. And we do have an example demo to just kind of an application of all of these beginner concepts that we just taught you, that we wanted to walk you guys through. But first, any questions before we get into this? All right. So this, first I'm going to demo it, then we can talk about the actual code and like what it means. Can you guys see my screen? Do you see code? Perfect. First of all, this website is called Replit. It's perfect for beginners who are trying to collaborate with people. Highly recommended if you're a beginner doing a project with a team. It's basically like Google Drive. Like you see your other users in the corner, you can all edit it asynchronously like you would on a Google Drive document. And yeah, that's basically what Mega and I did when we made this example. So let's run it. So first of all, to kind of reiterate, when we run this program, it is taking in all the lines one by one and making sure that it understands each of the lines and that it's abiding by the language that we both agreed upon, which is the syntax of the Java programming language. And as you can see, since it's actually it compiled. It understood all of the instructions that we gave it. You see that it's asking us, hello, and welcome to guess the number. You'll be tasked with trying to yada, yada, yada. Let the game begin. Please enter a guess between 0 and 100. As you can see, that's just the text that we include in our main method. When you click run, it will just run the main method here, and it will go run it one by one. And I'll talk about scanners at the end, but effectively what it's doing is that please enter a guess, a number between 0 and 100. You get 20 tries to guess the number. So I'll say 1. Oops. Something broke in the past hour. What have to do with it? Yeah, this is what happens live. Yeah. Let's see. Oops, sorry, I accidentally put that in chat. All right, perfect. So I say 2, my guess was too low. All right, so then I guess the number that they generated is higher than 2. Let's just try 13. Still too low. 40, still too low. 60, still too low. 80, still too low. 90, interesting, still too low. 100, too high. That's fair. 99, too high. 95, too high. 92, too low. 93, oh, I lost already. Shoot. All right. Well, I lost the game. But that's just basically how this very simple game works. It'll take a user input. It'll check whether it's higher or lower or equal to a random number that it generated itself. And it'll count the number of tries you've had. And after you run out of tries, if you haven't guessed the number, you lose. If you do guess the number, you win. So I guess we can just walk through the actual code behind that now, right? Does that sound good, Chester?
Yeah.
Do you want to start with the main method, maybe?
Okay. Yeah. So basically the main method is super short, and this is usually a good thing because you try to like have like other methods that do like that are like segments of code that do specific things, and then your main method is just like it'll call one of them or do some like really basic stuff to keep the code modularized. So as you can see here, the main method is creating this scanner object, and scanners in Java are basically this this object in this class in the Java util package that you can import, and it'll help you read in keyboard input from the user. And so like our main method just prints out some instructions, and then it calls the play game method with the scanner object that we'll be using.
A little bit more about the scanner object. In Java, that's basically how you get user input from the command line. If you are making some sort of Java application, you'll probably be using it. So in this case, it's taking in the scanner object because when you say play game, you need to have access to the scanner object to understand the user's input. That's all. So play game, as you can see, it's private. Does somebody in the chat want to tell me what it means when it's private? Actually, same for static and for void, actually. Different people. It's tough with Zoom because you don't know when people are typing. I don't know if you all just aren't comfortable responding or if you're taking your time to type. All right, it's okay. We'll credit you if you got it right, but I'll move on and explain it. Again, private is just who can access this method. As you can see, private doesn't really matter because we're in the same class main as the main method. So private's fine. It could be public too. It wouldn't have any negative implications. Static is because we're not working on an instance of a main. In fact, you never work on like an instance of a main. There's no like main object. So if you just have a simple program with one main class and one main method that calls different methods, then your methods would be static. Void is because it doesn't actually return anything. It does give you some output, but it's not actually returning something, which is then again used in the main method. If it did, then you'd say what the return type is. And then play game has the parameter of the scanner because we need to use the scanner to get the user input in the game. So we start out by declaring these 4 variables. So to play the game, 1, we need to know how many rounds have been played. Right now it's 0. Whenever the game starts, it'll start at the top of the method and it'll start declaring the number of rounds done as 0. And we also need to know what the maximum number is. You could also program what the minimum number is, but we just set it as 0 here. But you could also say int min number equals 0. And then you have a Boolean of whether the computer won or not. You don't have to declare it, but you could default as the computer has won. The computer is winning until the user wins the game. And if the user does win the game, we will change that Boolean. And finally, we have a random number. You can Google how to make a random number and how to do it within a range, but essentially, you have a math library that you call. You will learn about that. It's basically you just do math.random times the maximum number. And then you have to make it an integer because when they say a number is random, they truly mean random, like it'll have multiple decimal places afterwards. But that's just effectively how we picked a random number between 0 and 100. Do you want to explain this next part, Chesta?
Yeah, sure. Also just wanted to point out that we have this like while loop to like keep track of the number of rounds. And so like we have like a limit on like 10 rounds, right? So this is
I have
one
a
of those
question actually,
examples.
Shasta.
Yeah, what's up?
Why is this a while loop as opposed to a for loop?
Yeah, that's what I was gonna point out. Basically, it's one that can be converted to a for loop because you see like at the end, like you have num rounds plus plus. It's like you can have the for loop defined as like for num rounds equals 0, then while num rounds is less than 10, and then num rounds plus plus as those like 3 things in the for loop. But like intuitively in this context of the game, like I think a while loop just makes more sense. Obviously you could do it as a for loop and it would work just the same, but intuitively it makes more sense as a while loop just because like when you think of the game, you say like the game runs until like you guess the correct number, right? Like a for loop is more for situations when you know how many times like the condition or the block of code will execute. And in this situation, we don't really know how many times it will. It will be less than 10, but it could be 1, it could be 9, it could be 10. So it makes more sense as a while loop here.
Yeah,
But
so
that
basically,
makes sense.
while like it'll only keep asking for numbers while you are within like the number of rounds allowed in the game.
Like when you define the problem statement of whatever we're writing, or like when you define the game, instead of saying like it runs for 10 times until you guess the right time and then it might cut off, you just say it runs while you haven't guessed the right number yet. So a while loop just makes more sense intuitively.
Mhm.
Yeah.
If you had a for loop, it would ask it 10 times unless you broke out of the loop once they got it right, which is just more complicated.
Yeah. And then we have this last part here, the endgame method. Basically what this does is it takes that value, computer 1, true or false, and it returns, it prints out like the appropriate statement. So if the computer 1, if that was true, then it prints out you lost. And then if the computer didn't win, in which case it would be like computer 1 would be false. It prints out congrats on winning the game, because that means that you guessed the right answer. Because in line 51, it sets computer 1 to false if you guessed it.
I do want to look at these if statements pretty specifically, just to make sure you all get the different comparison operators. As you can see here, num input is sc.nextLine, which means the scanner object's next line is equal to the string num input, and string being the series of characters that the user typed in. Now, to actually use that as a number and see whether it is a guess that's too low or too high, to actually compare it to other numbers, you have to convert it into an integer. And that's what this line is doing. This line is saying int num, which is integer num equals, and then the integer class has a method called parseInt, which will take in a string and output it as an integer. So you do have to convert it to an integer just so you can compare it to other integers. So that's where you get the number. So first to check you have to do is check whether or not it is in the range. And I forgot who asked, but this is a good example of why you'd use else if instead of another if statement. Basically, if their first guess is one that's not valid, you don't care to check whether it's greater than or less than the number. You don't care to let them know whether their guess was too low or whether their guess was too high. The only information that they need to know is that your number is outside of the range. You're not even following the rules. Same goes for if somebody guesses a number where the number they input is less than the random number. If that's true, and we let them know your guess was too low, we don't also have to check whether their guess was too high, because it wouldn't be. You can't be higher and lower than a number at the same time. So it goes through those one by one. If it's not lower, then it'll check if it's higher. And if it's not higher or lower, that's when you know, and it's within the range, that's when you know you got the right number. And that's when it changes the output of the winner to false. And that's when it breaks out of the loop. This is a break statement if you ever want to break out of a loop. And it'll go here and it'll, as Jessica said, conduct those end game statements. All right, that's pretty much it. It's totally fair to have a lot of questions. We can answer a few right now. We will also be in the Discord, same names, Vishen, Shasta, Akil, if you ever want to DM us. But for now, does anybody have any questions that they think other people may have to? Any specific lines in this program that you don't get? Yeah, we will link the code and the presentation slides, as well as resources to kind of like learn Java and remember all this syntax. Nikhit, would a good place for that be the workshop channel? I don't know if you heard. Or Hashida.
Yeah.
Great question, Sagar. Oh,
We're
sorry.
Recording
Hi.
this anyway, so you're gonna get like a YouTube link with all the videos of like basically all the workshops, so don't worry about it.
Oh,
Excellent.
yeah. Sorry about that.
So yeah, Sagar asked a great question. How do you comment code? So for people who don't know, that is something you can do. Of course, a lot of this seems like gibberish and you may forget what it is, or when other people read your code, they may not understand what it is. And that's when commenting on it is helpful, much like you would like comment on like a Google Doc to kind of explain your reasoning for something. So in Java, it is just a double slash. So if you do double slash, you'll see this text is gray. This has no impact on the compilation or the running of the program. As soon as it gets to this line, Java will see the double slash and it'll skip right over it. So here you can say 2 slashes, this method actually plays the game with the user. And when you share this with your friends and they want to understand what this method does, they'll see that right here. Me here asks, does the hash not work in Java? The hash is how you comment in Python. If you see it in Java, it just won't do anything. It's just not within the Java language. And yeah, you would think maybe they'd have some uniformity, but they don't. Commenting will be different in every language. Printing something out will be different in every language. It's annoying, but you do get the hang of it and you start remembering which one is which.
Yeah, and just to add on to that, you can comment like multiple lines of code as well. If you do like slash asterisk and then close it with an asterisk slash.
Let's
Roshan,
do
could you
that.
demo that?
I don't want these lines. So I actually forgot the exact syntax. The star or slash
Yeah.
star star.
Slash asterisk.
Asterisk,
You only need
asterisk.
one asterisk.
Okay. See, I have coded in Java for
But,
4
like-
years and I don't remember these things. Like you aren't expected to memorize this language.
And like depending on the like editor you use, it'll like help you with a lot of it. For example, like this the slash asterisk asterisk, that is usually used in like documentation when you document your like methods and stuff. That's how it will look. So like there's just different like conventions for things.
Yep.
Yeah.
As for editors, by the way, I guess that is a fair conversation to have. Depends to the extent of which you want to do stuff. REPL is a great online virtual collaboration editor. You can have like a whole file system in here too. But if you really want to get into programming with Java, you'll want to like download a text editor, which function is to like code. Those are often very helpful because they have debugging tools. They have good UI to just see outputs and inputs of different statements. One I used in high school was Eclipse. I don't know if Shasta or Akil have any favorite text editors.
My favorite is probably VS Code. I use it for everything.
That's
pretty
true for
good.
Virtual Studio Code. Yeah, it's very much similar to this, except you'll have a bunch of toolbars that can help you write code.
VS Code
Use
also does
Atom.
oh sorry. What was it?
I use Atom.
Okay.
I'm pretty sure. I think Eclipse is a IDE, slightly different.
Oh yeah, do you want to explain the difference?
Yeah, so text editors are basically a little more bare bones. You can add on a lot of plugins and stuff like that, but at the end of the day, it just like kind of helps you format your. It's just a text editor where you can type in any kind of text. IDE stands for Integrated Development Environment. Usually, they have a little more complicated debugging tools and stuff like that. And they require a little more like resources to run.
Like in an IDE, you'll get a red underline if you don't match the right syntax. Stuff like that.
Anyways, thank you guys for attending our workshop. If you have any more questions, again, we're here to answer them, as mentioned.
Me here, I use Eclipse in high school. I do use more like Atom now. I'd say I do use Atom.
IntelliJ is all right.
Yeah.
I switched, so I used to use Eclipse a lot, but then I realized it was very like I don't know, it took up it was very slow sometimes. So switched over to VS Code mainly.
Everyone has their preferences. If you're a beginner, you could probably just Google best beginner. And yeah, that is